Okay, so we have already started unit number 2, and that is nothing but the problem for search algorithm. So there are two types of search algorithms. In the last time we have seen, one is uninformed search and the other one is an informed search. Now, as far as the uninformed search is concerned, we have already seen that this type of algorithm is called as a blind search algorithm. It does not have any domain knowledge, and it is also called as a brute force algorithm because here we actually have the we actually have the information about how to traverse the given tree and how to find the goal state, and it behaves like a brute force way, and hence it is called as the uninformed search. We have also seen the uninformed search. There are 6 types of categories, strategies. These 6 strategies are breadth first, depth limited search, iterative deepening depth first search, bidirectional search, and uniform cost search. Now, these are the 6 type of strategies mostly used in uninformed search. Now, we have seen the first as called as a breadth first search. So it actually normally starts from root node, then examines the neighbor node, and then it moves to the next level. It is based on first in, first out strategies. And through this strategy, it finds out the shortest way for achieving the solution. It requires very small and it is applicable for the small problems, and the space complexity is also not considered. This is the example how it goes like. So we have A as a root node and F is the goal node. So how it goes, it starts from A, travels to the next level, that is visits B and C, then travels to the next level called as D, E, F, G. Here the goal state is defined as F, and hence it will stop at F. This is how the breadth first start. So how it will go? It will start as A to B, then from B to C because it's second level, first level, B to C, and then from C to it will move to the next level, D, E, and then F. This is how we have seen the breadth first search. Then we went on to go for depth first search. It is based on a LIFO strategy, that is last in, first out. And one more different thing in this search is it goes backtracking. That means it will start from the initial state, explore each of the path to its greatest depth, and then it will move to the next depth. So next path. So it will start from the root node to left node, and then it will move to the right node. So how it can go? Obviously, it will start from A, it will travel to B, then it goes to D. Then after that from D, it will go backtrack to B. है ना? A, B, D. D से फिर जाएगा B. वो देखेगा कि B already existed है. So B से वो जाएगा E. Correct? E से फिर जाएगा B की तरफ. फिर देखेगा कि B तो ऑलरेडी है, A ऑलरेडी है, सो E से उसको नेक्स्ट लेवल पे जाना है तो किधर जाएगा? C जाएगा, और C से जाएगा F. In this way, the F will be our goal state and it will stop here. This is called as the depth first search. So you can see from A, B, D, E, C, and F. So there are some of the advantages as well as disadvantages of DFS. The most important is that it does not guarantee you to give a solution. That is what the disadvantage is. And there is always a possibility because of the depth that it may be trapped in the infinite loop. So all these limitations has to be overcome in another search strategies. Then we just a moment. Now we'll move on to the new one called as a depth limited search. Now in this depth limited search, actually whatever there is limitations of DFS, it will be completely tried to removed in case of depth limited. So its search solves one of the drawbacks of DFS, that it does not go to an infinite path. So वो loop में अटकने का जो issue है किसका? Depth first search का, वो निकालने की कोशिश करता है depth limited search. And DLS actually ends its traversal if any of the following condition exists. So क्या conditions है? Standard failure. It denotes that the given problem does not have a solution. ठीक है, वो end हो जाएगा अगर ऐसा हो तो. दूसरा है कट ऑफ फेलियर वैल्यू, इट इंडिकेट्स दैट इज नो सॉल्यूशन फॉर द प्रॉब्लम विद इन द गिवन लिमिट, उस लिमिट में उसका कोई सॉल्यूशन नहीं है, अगर ये दोनों में से एक भी कंडीशन वो फॉलो करता है तो वो एंड हो जाएगा, दैट मींस डीएलएस विल एंड इट्स ट्रैवर्सल इफ एनी ऑफ द फॉलोइंग कंडीशन एग्जिस्ट, अगर वो दोनों कंडीशंस एग्जिस्ट होते हैं तो वैसे भी वो टर्मिनेट हो जाएगा। सो क्या डिफरेंस है इसमें, डेप्थ लिमिट सर्च में डीएफएस का जो इन्फिनाइट पाथ का जो इश्यू है वो रिमूव करता है, और दूसरी बात दी डीएलएस एंड्स इट्स ट्रैवर्सल if it follows one of the following conditions, that is standard failure, that means it denotes that given problem does not have a solution, and second, that no solution from the problem within the given limit. So there are two different things that comes here under standard failure and cut off failure. So these are the things that actually depth limit search overcomes, especially of DFS. So how it overcomes, तो अभी उन्होंने क्या किया है कि उन्होंने लेवल तय किया है ना, तो लेवल कैसे है, लिमिट 0, लिमिट 1 एंड लिमिट 2। सो अगर यहां पर देखोगे ए लिमिट 0 में आता है, लिमिट 1 में बी और सी आता है, और लिमिट 2 में डी ई एफ जी आते हैं, तो लिमिट के हिसाब से यहां पर ट्रैकिंग होगी, करेक्ट। सो कैसे होगी, लेट्स स्टार्ट विथ ए एज अ स्टार्ट नोड एंड सी एज अ goal state. So A is the starting node which is at limit 0 and C is the goal node which is at limit 1. So obviously limit 1 diya hai, that is limit as 1, and we have a goal as C. Now the traversal first starts with node A, then it goes to the next level. जैसे वो level 1 में आएगा उसको दो ही चीज दिखाई देगी, B और C, and the goal state C will be in that first limit, and hence it will stop here. So what will be that, it will be A to C. Have you got it? It's simple, because of the limits you can easily find out where your goal state is. Now if we give C as the goal node, ठीक है, and limit as a 0, अगर मैंने बोला कि C नोड मुझे जाना है, लिमिट 1 की जगह पर लिमिट 0 पे जाना है, तो फिर क्या हो जाएगा, उसे कोई पाथ मिलेगा ही नहीं, क्योंकि वो लिमिट 1 में C है, लिमिट 0 में उसको C दिखाई नहीं देगा, तो वो जाएगा नहीं आगे, बराबर, because the algorithm will not return any path of the goal node is not available within the given limit. अब और एक केस लेते हैं कि if the goal node is F, suppose this is F and the limit is 2, so it will be limit is 2 and it will be F. So how it will go, again it will go to A to C, so देखेगा कि B और C में दोनों में भी नहीं है, बाद में देखेगा डी ई एफ जी में कौन सा है, तो एफ है, तो जाएगा ए से सी और सी से एफ. सो दिस इज हाउ इट विल गिव अकॉर्डिंग टू द लिमिट्स. सो अगर मैंने बोला कि एफ को ढूंढो और मैंने लिमिट 0 दी है, तो वो टर्मिनेट हो जाएगा, क्योंकि वहां पर कोई गोल नोड अवेलेबल नहीं है. सेम थिंग मुझे एफ को दिया है और लिमिट 1 दिया है, तो इस जगह पे वो आएगा और देखेगा कि एफ तो उस लिमिट में नहीं है, तो वो टर्मिनेट हो जाएगा. इसका मतलब वो अवेलेबल नहीं होने की वजह से वो वैल्यू कोई देगा ही नहीं. और थर्ड केस हमने जो देखा कि हमने लिमिट 2 दिया और एफ दिया, तो उसको जाने के लिए 3 लेवल्स पार करने पड़ेंगे. सो लेवल 0 से वो जाएगा लेवल 1, वहां पर उसको एफ दिखेगा नहीं, लेवल 2 में जाने के बाद उसको एफ दिखेगा, लेकिन कहाँ है एफ, सी के बाद है, तो वो ए से सी जाएगा और सी से बाद में एफ जाएगा. सो दिस इज ए सी एफ विल बी the path or the goal node that it will identify. This is the best example of a depth limited search. Now what are the advantages of this depth limited first search is the depth limited search takes lesser memory as compared to the other search techniques. क्योंकि यहाँ पर उसे पूरा ढूंढने की जरूरत नहीं है, वो उस लेवल पे सिर्फ वो पर्टिकुलर नोड ढूंढेगा, and that's why it is very easier to find out the particular goal. It doesn't have to go to each and every level and each and every node to find out the things, and henceforth it will take lesser memory as compared to the other search strategies. But as we know that there are always advantages as well as disadvantages, so this depth limited search is also having some disadvantages. So what is that limitation? So DLS may not offer an optimal solution if the problem has more than one solution. So एक से ज्यादा अगर solution होगा तो वो optimal solution नहीं देगा. And DLS also encounters the incompleteness. सो थोड़ा सा देखने के बाद पता चलता है कि ये अल्गोरिदम पूरा कंप्लीटली वर्क करता है या नहीं करता है. So you can find that there is something incompleteness is there in this type of algorithm. So these are some of the disadvantages. It may not give an optimal solution, and it also encounters the incompleteness. These are the two limitations that DLS search algorithm will have. The next one is an uninformed search, under which we are going to see iterative deepening depth first search. So as the word is iteration, so you have number of iterations. है ना? Deepening, obviously it will go deeper. Depth first search, that is also called as IDDFS. Now the IDDFS is actually nothing but it's a combination. So it's a combination of a depth first search and a breadth first search. So these two techniques will be combined together. That means it will have a limitations as well as it will have the as well as it will have the levels also are there, and a particular node will also be there. So the combination of a depth first search and breadth first search will be here. Now actually IDDFS finds the best deep limit by gradually adding the limit until the defined goal set is achieved. Now what is the difference? You'll come to know about these combination of two. Now what will happen is that let us consider that A is the node and E is the goal node. The maximum depth will be 2, so that is 0 to 2. It will be having limit number 2. The algorithm starts with A and goes to the next level and searches for E. यहाँ से वो जाएगा E ढूंढेगा, B और C मिलने की वजह से वो नहीं ढूंढ पाएगा, और उसका सेकंड डेप्थ में E उसको मिलेगा. So the path of the traversal will be A, B and E, because once it goes to the level 2, as the depth is of limit 2, because it will go to the depth 2. So depth 2 means limit 2. So it will search out E there, and you'll find out that E will be easier to go from B. So A, B and E. Now how it works out, that we are going to see. Okay, how it works out? It works out in a very simple way, like only it will have an iteration, that word is added, and the combination of two searches will be there. So you're getting to the node also, as well as you're understanding the limit also. So that is nothing but the iterative deepening depth first search. So this is about the algorithm that it works out to be. Now comes bidirectional search. Now bidirectional search is somewhat different from other types of search algorithms. Actually here we execute two types of simultaneous searches called as forward search and backward search, and then it reaches to the goal state. Now what it means forward and matlab kaise ki suppose there is A and there is the first node is A and the last node is G. So what will happen? It will start from A, it will keep on searching, and from G it will keep on searching. दोनों तरफ से सर्च होगा चालू. जैसे ही वो एक जगह पर आ जाएंगे जहां पर वो कॉमन नोड पर आ जाएंगे, वो टर्मिनेट हो जाएगा. जिस वक्त वो टर्मिनेट हो जाएगा, आप बता पाओगे कि ये बाय डायरेक्शनल सर्च है. Is it okay? Like example we can see here. I'll give you the example also. The bidirectional search algorithm is completely different from all other search strategies. It executes two simultaneous searches, that is forward search and backward search, and reaches the goal state. Here graph is divided into two smaller subgraphs. In one graph, the search is starting from initial state, and the other graph, the search will start from the goal state. बराबर. Suppose A अगर initial state है और G मेरा destination search है, तो destination search और initial search ये दोनों भी आपको डिफाइन करने पड़ेंगे, तभी आप ये काम कर पाओगे. और फिर इजीली वो दोनों साइड से ट्रैक हो जाएंगे. जिस जगह पर वो कॉमन पॉइंट पर आ जाएंगे वो टर्मिनेट हो जाएगा. इस तरह से मैंने मेरा जी भी ढूंढा और ए भी पता किया, यानी ए भी मुझे मिला और जी भी डेस्टिनेशन नोड तक मैं पहुंच गया. इसका मतलब ये होता है when these two nodes intersect with each other, the search will be terminated. Okay, so जैसे वो एक जगह पर आएंगे उस जगह पर सर्च टर्मिनेट होगा. सॉरी. Bidirectional search requires both start and goal start to be well defined and the branching factor to be the same in two directions. So iska sabse bada important yahi hai कि both start and goal start should be well defined and the branching factor to be the same in two directions. यानी कि क्या, ब्रांचिंग फैक्टर भी मालूम होना जरूरी जो दोनों डायरेक्शंस में जाने वाले हैं. ओके, क्योंकि अगर ब्रांच थर्ड रही तो वो फिर ढूंढ नहीं पाएगा क्योंकि टर्मिनेशन होगा नहीं जहां पर वो दोनों मिलेंगे, इंटरसेक्ट हो जाएंगे. तो इसका मतलब मुझे ये भी पता करना जरूरी है कि वो टू डायरेक्शंस में ब्रांच फैक्टर भी इंपॉर्टेंट बनेगा. अब यहां से आप पता कर सकते हो, देखो. नाउ द गोल सेट इज ई, नहीं सॉरी, द स्टार्ट इज ई and the goal is G. Okay, so the start is E, the goal is G. So now what will happen? The start state is E, the goal state is G. In one of the subgraph, the search will start from E. yahan se shuru hoga. The search will start from G. दूसरे इसमें से G से स्टार्ट होगा. बराबर. तो दोनों तरफ मैंने देखो दोनों ब्रांच ग्राफ में, सब ग्राफ्स में मैंने दोनों भी डिफाइंड किए, इनिशियल नोड भी डिफाइंड किया है और डेस्टिनेशन नोड भी डिफाइंड किया है, दैट इज अ गोल नोड. सो एक जगह पर वो ई से स्टार्ट होगा, दूसरी जगह पर वो डी जी से स्टार्ट होगा, है ना. सो नाउ व्हाट विल हैपन, ई विल गो टू बी एंड बी टू ए. इन केस दिस जी विल गो टू सी एंड देन इट विल गो टू ए. अभी दोनों ए पे आ गए, मतलब वो टर्मिनेट हो गए. As both the traversals meet at A, hence the traversal will end. Hence the path will be E, B, A, C, and G. Is it okay? How the path will go? Again, once again, I will say, you have an initial search as E, and your goal search is G. So this is initial node, start node. This is the destination node, that is G. In both the subgraphs, you have to define initially that which is the search, which is the start node and which is the end node. So in the first graph, it will start, the search will start from E, it will go to B, then it will go to A. Right? Now from the other side, the other subgraph, now here the node, instead of starting to E, it will start from G. So now from G it will go to C and it will reach A. Now both the graphs will reach at A and hence it terminates. So now what will be the total path that is you are finding out, traversal path? The traversal path will be E, B, A, C and G. क्योंकि यहां से A तक पहुंचे और यहां से A तक पहुंचे. So A पे टर्मिनेट हो रहा है, इसीलिए आपका जो ग्राफ है वो बनेगा E, B, A, C and G. This is how the bidirectional search will work out. यानी कि it will start from both the nodes, that is the root node and the destination node. Now what are the advantages of bidirectional search? This algorithm searches the graph first, है ना, फास्ट हो रहा है क्योंकि दोनों नोड डिफाइंड है, सब ग्राफ्स में एक जगह पे आके टर्मिनेट हो रहा है तो फास्ट हो रहा है. It requires less memory to complete this action. Obviously there is no level in this, so it will be faster, it will have less memory. But as you know that there will be some disadvantages also. First disadvantage क्या है कि goal state और root node state ये दोनों भी अच्छी तरह से प्री-डिफाइंड होने चाहिए, बराबर. And second most disadvantage is that difficult part about this is कि the graph is quite difficult to implement. Now as there are very less node here, it looks simple, but if the nodes are very large, then you will be having number of subgraphs also. So number of subgraphs will be more, and then reaching to that particular point will be difficult to identify. And henceforth, these two are the most important drawbacks. That is difficult to implement, and second is that the goal state has to be predefined. This is called as the bidirectional search. Now comes the uniform cost search. This is also quite interesting search. ये आप सारे सर्च देखोगे ना तो इतना मजा आता है एक्चुअली करने में कि once you start doing this search, implement these search, you'll find it very interesting. They are having some kind of logics. Each and every search is having different logic. Some of them look similar, but they are different. So this is completely a weight based. जो हमने आर्टिफिशियल न्यूरल नेटवर्क में देखा ना, वेट एंड बायस एंड ऑल दोस थिंग्स, सिमिलरली इसमें वेट है. सो वेट कहाँ होगा? सो आप इन सारे नोड्स को देखोगे तो पता चलेगा कि इसमें बहुत सारे नोड्स है, नेबरिंग नोड है, एक स्टार्ट नोड है और एक डेस्टिनेशन नोड है. अब ये नोड में जाते समय बहुत सारे ब्रांचेस है और हर पाथ को एक वेट दिया गया है. दिख रहा है 6, 5, 10, 6, 6, 7, 6, 6, 6, 1. अब इन नोड्स को वेट दिया है तो सबसे लोएस्ट वेट वाला जो पाथ रहेगा, लोएस्ट वेट, वो पाथ आपका सबसे इजी पाथ होगा रीच होने के लिए डेस्टिनेशन. राइट? इसका मतलब द यूनिफॉर्म कॉस्ट सर्च इज कंसिडर्ड टू बी एज अ बेस्ट सर्च फॉर वेटेड ग्राफ. यानी जिस ग्राफ में वेट की वैल्यूज होगी या ग्राफ विथ कॉस्ट दिया होगा, उस जगह पर यूनिफॉर्म कॉस्ट सर्च बहुत काम करता है, बहुत इजीली काम करता है. बराबर? सो दैट मीन्स किसे प्रायोरिटी दी जाएगी? सो इट विल बी गिविंग द मैक्सिमम प्रायोरिटी टू द लोएस्ट क्यूमुलेटिव कॉस्ट. यानी कि जिसका लो वेट होगा उसको पहली प्रायोरिटी दी जाएगी, है ना? तो पाथ भी हमको मिलना चाहिए, लोएस्ट पाथ. तो वो पाथ कैसे देगा? Obviously, the uniform cost search can be implemented using the priority queue. So it's like a queue. Now how it will go? So obviously there will be 4 different paths. So the S will be the starting node, G will be the goal node. So the first path will be from S, it will go to A, then E, then F, and then G. So what will be the weight? Weight will be 6 plus 12, 6, 12, 12 plus 6, 18 plus 1, 19. So you can see the first one is 19. The weight is 19. Second will be S, B, E, F, and G. So it will be 5 plus 6, 11 plus 6, 17 plus 1, 18. So this path will be having the weighted cost as 18. The third path will be S, B, D, F, and G. So it will be 5 plus 7, 12 plus 6, 18 plus 1, 19. So again, there will be 19. And the last path will be S, C, then it will be D, F, and G. So 16 plus 6, 22 plus 1, 23. So this will be having the highest and this will be having the lowest. So highest and lowest, that means what? We have to find out which maximum priority is given to the lowest cumulative cost. And hence we have the lowest cumulative part as this path. So this path will be S, B, E, F, G. And hence in this way, with the help of uniform cost search, we can find out the shortest path from S to G. Now, what are these advantages of UCS and what are the disadvantages? So advantage is that this algorithm is optimal as the selection of path is based on the lowest cost. So obviously we can say that it is an optimum. Why optimum result is giving? Because it has been searching the paths on the lowest cost. But as we know that there will be some disadvantages of this search also. So here the algorithm does not consider how many steps it goes to reach the lowest path. इसमें कितने steps में जा रहे हैं हम, इसमें कुछ identify नहीं होता. और दूसरी बात कि this may also result in an infinite loop. तो यहाँ पर बहुत से कम लूप है क्योंकि 4 ही लूप आ रहे हैं तो इतना कुछ डिफिकल्ट नहीं है, लेकिन बहुत सारे नोड्स होंगे तो उस जगह पर इनफाइनाइट लूप में जाने की प्रॉब्लम हो सकता है, जा सकता है ये. So these are some of the disadvantages as well as the advantages of the uniformed cost search. So there we have seen the all five, I mean six. These are the six strategies: breadth first, depth limited, iterative, bidirectional, and uniform cost. So we have finished this uninformed search. Now we'll move on to the informed search. So we have finished the uninformed search. Now we are going for the informed search. This informed search is also called as the heuristic search or a directed search. There is a direction to that search. कोई तो भी एक direction है. In contrast to the uninformed search algorithms, the informed search algorithm require details such as distance to reach the goal, steps to reach the goal, cost of the path, which makes this algorithm more efficient. So uninformed में ये सब चीजें नहीं थी. Informed में आपको ये सब चीजें देनी पड़ेगी. क्या देना पड़ेगा? पहली बात तो इनिशियल नोड और डेस्टिनेशन नोड का डिस्टेंस, द स्टेप्स टू रीच द गोल, द कॉस्ट ऑफ द पाथ. All these three things will make it efficient algorithm. As the goal state can be achieved using the heuristic function, so obviously we are using the heuristic function to reach from the start node to the destination node. Hence it is also called as the heuristic search. The heuristic function is used to achieve the goal state with the lowest cost possible. Obviously the cost has to be lowest, and this function estimates how close a state is to the goal. So ये पता चलेगा कि हम गोल के कितने नजदीक है. So ये function है heuristic function जो बताता है. Let's discuss some of the informed search strategies. So जैसी uninformed search strategies 6 थी, इसमें भी आपको कुछ strategies study करना है. First is a greedy best fit search algorithm. Second is a star search algorithm. So there are two best search strategies in this informed search strategies. The one is a greedy best fit search algorithm, and second is an a star search algorithm. Let us start with the first one. Greedy best fit search algorithm. It uses the property of both depth first search and breadth first search. Again, so we have seen different properties of the search algorithms. So out of these search algorithms, it is going to take the properties of two search strategies that are being used in the uninformed search, that is the depth first and breadth first. So greedy best fit first search traverses the node by selecting the path which appears best at the moment. The closest path is selected by using the heuristic function. Now, only difference between the other uninformed search and in case of informed search is that you will be using a function here. वहां पर हमने कोई फंक्शन नहीं यूज किया. वहां पर हमने सर्च एल्गोरिथम के लॉजिक्स लगाए, अलग अलग तरीके से हम गोल तक पहुंच पा रहे थे. लेकिन इस जगह पे क्या है, हम एक फंक्शन यूज करने वाले हैं और वो फंक्शन है ह्यूरिस्टिक फंक्शन. इस फंक्शन की मदद से हम एक्चुअली नोड को स्टार्ट से इनिशिएट कर गोल तक पहुंचेंगे. आर यू अंडरस्टैंडिंग द डिफरेंस? बिकॉज यहाँ डायरेक्शन तय है, वहां पर कोई डायरेक्शन नहीं था. वहां पर जस्ट it is not knowledge domain, right? It will start from something and it will go to that. But in this case, you have the direction because you have the distance, you have the path, all thing is suggested, and the function is properly used in order to search the node. Now you can see that there is an node. So you have A as the start node and H is the last node, that is the goal node. There are heuristics that have been defined for a particular node. So A will be 13, B will be 12, C will be 4, D will be 7, E 3, F 8, G 2, and H as 0. So this is the goal state and this is the starting node. Now how it will reach and how it will use these heuristics to reach from A to H. So A is the start node and H is the goal node. It will start with A, then examine the next neighbor B and C. So it will go with B and C. So it will see that B is 12 and C is 4. So the best path at the moment is C. Correct? यहाँ 12 है, यहाँ 4 है, तो किधर जाएगा? Obviously वो 4 की तरफ जाएगा because lowest cost है. The best part at the moment is C. Hence it goes from C, it will explore F and G. What is F and G? F is 8, G is 2. So G तो 2 देखेगा, ये तो lowest path है, तो G तो जाएगा, तो C से लेकर G में पहुंच गया, बराबर. So obviously heuristic path के हिसाब से F 8 है, G 2 है, so C से वो जाएगा G की तरफ और G से वो जाएगा H की तरफ because H 0 है. Hence we have achieved the goal state. This is called as the greedy best fit search algorithm. It's very simple algorithm. Once again, I will explain you what will happen. It will start from A. A is having 13. It will move to 2 nodes, B and C. B is 12, C is 4. So lowest cumulative 4. A will move to C 4. Again C से जाएगा 2 नोड की तरफ, F और G. F is 8, G is 2. So again lowest cumulative it will go to G, and from G it will go to H because it is 0, and hence the path will be A, C, G and H. This is called as the greedy best fit search algorithm. What are the advantages? So the advantages are nothing but they are more efficient compared with the breadth fit and depth fit, depth first and breadth first search. There are some of the disadvantages. In the worst scenario, the greedy algorithm behave like an unguided DFS. कभी कभी लगता है कि डेप्थ फर्स्ट जैसा सर्च करता है, लेकिन वैसा है नहीं. कोई अगर वर्स्ट सिनारियो हो, वर्स्ट केसेस हो, तो उस केस में इट विल लुक लाइक द डेप्थ फर्स्ट सर्च. अदरवाइज it will work as in worst scenario only. There are some possibilities for the greedy best first to get trapped in the infinite loop. Again, this is quite a common disadvantage in most of the searches. लूप में अटकने के चांसेस बहुत ज्यादा है क्योंकि नोड्स बहुत ज्यादा होंगे. सो नोड इनिशियल नोड से डेस्टिनेशन नोड की तरफ जाना है और बीच में बहुत सारे पाथ है, बहुत सारे नोड्स है. सो समटाइम्स इट मे बी trapped in this infinite loop. The algorithm is not an optimal one, so it doesn't give you an average, above average performance. This is the disadvantage. So we have already discussed the path of the traversal, that is A, C, G and H. So this is the first one called as the greedy best fit search algorithm. Now second one is the A star search algorithm. It is the combination of both uniform cost search and greedy best first search algorithm. So again, you will be having a combination of two. The uniform cost search, जो last वाला देखा था ना हमने heuristic अपना uninformed search algorithm में, the last one, right? और greedy best first search को दोनों को combine करके एक और एक algorithm बनाया है. It uses the advantages of both with the better memory usage. It uses the heuristic function to find the shortest path. Obviously वहां पर का भी यूज करके, वो वाला फंक्शन यूज करके heuristic फंक्शन भी यूज कर रहे हैं, तो दोनों का एक एडवांटेज मिलेगा A star search में. As it uses the sum of both cost and heuristic of the node to find the best path. So वहां पर हमने देखा था कि कॉस्टिंग निकाली थी पाथ की, वो और ह्यूरिस्टिक दोनों का कॉम्बिनेशन करके हमने A star algorithm बनाया है. So how this algorithm works now? So let us assume that we have an diagram here. So we can see that how many loops are there. So one is A, B, D, E. There is also A, B, E. Then you have the another one, A, H. So A, B, E, A, B, D, then A to H, A, C, F, H, and then you have A, C, G, H. So according to the uniform cost, we have different the weighted sum is there ना, weighted values are there. So uniform cost जो है वो weighted value पे define करेगा. और बाद में heuristic function के लिए the values are also given, the heuristic values are given. So A is having 5, then the B is having 3, C is having 4, D is having 2, E is having 6, F is having 3, G is having 1, H is having 0. So आपको दोनों तरीके से काम करना है, एक तो ह्यूरिस्टिक फंक्शन का भी इस्तेमाल करना है और दूसरी बात है कि आपको यूनिफॉर्म कॉस्ट का भी इस्तेमाल करना है. दोनों चीजों को मिला के जो आपका एल्गोरिथम बनेगा वो ए स्टार्च एल्गोरिथम बनेगा. सो शुरू करते हैं. लेट ए बी द स्टार्टिंग नोड एंड एच बी द गोल नोड. सो इट विल स्टार्ट फ्रॉम ए. सो फ्रॉम ए इट विल गो टू बी एज वेल एज टू सी. सो B, C. So A, it can go to B and it can go to C and it can also go to H. So 3 रास्ते हैं उसके पास. A से वो B की तरफ जा सकता है, A से C की तरफ भी जा सकता है, A से H की तरफ भी जा सकता है. तो पाथ है उसके पास. So now from A to B अगर कैलकुलेट करेंगे, A से B, the cost of the heuristics, the sum of the cost and the heuristics will be A and B. So that will be 3. And here it will be 1 and 2. So it will be from A to B. A to B. Hello. Hello. Okay, so now we have to see the sum of the path cost as well as heuristic value to determine. Now, when it goes to A to B, the sum of the cost and heuristic will be 1 plus 3. So B will be 3 and the path will be 1. So 1 plus 3 will be 4. Now when it will be 1 to C, so the 2 will be there and the C value will be 4. So 4 plus 2, 6. Next will be A to H. So H will be 0, A will be 7. So 7 plus 0 will be 7. मिल गए? So A से B जब जाएगा तो 4 होगा, A से C जब जाएगा तो 6 होगा और A से H जाएगा तो 7 होगा. अभी इन दोनों तीनों को अगर कंपेयर करेंगे तो हमको लोएस्ट कॉस्ट कौन सा मिल रहा है? 4. तो 4 किस जगह पे था? B था. सॉरी, 4 किस जगह पे था? The lowest path is from A to B. Yes, from A से B था. So A to B is chosen. The other path will be on hold. बाकी के सारे paths hold पर है. Now from B it can go to D or E. B से again D जा सकता है या फिर E जा सकता है. बराबर. So अगर A B से D गया तो D की वैल्यू 2 है. So 4 plus 2 6 और ये ऊपर वाला 1 है 7. So A B D. So it will be 4 plus 1 5 और D की वैल्यू 7. तो इसका वैल्यू कितना बन रहा है? 7 बन रहा है. अभी A B E. So 1 plus 6 7 और E की वैल्यू 6. So 7 plus 6 कितना बन रहा है? 13. So इसमें लोएस्ट कौन सा है? 7. So A B और D. So A B D the lowest path मिलेगा compared to the other paths which are on the hold. Now here path A to C of low cost, that is 6. So C 4 है और A value 2 है. So 2 plus 4 will be 6. बराबर. So इस जगह पे 6 आ गया. Now from A to C is chosen and other path is kept on the hold. Now from C it can go to F and go G. अभी C कितना है? Actually C is 3 and F कितना है? 3. So 3 plus 3 will be 6 plus 2 8. So इस जगह पे 8 है. C to G जाने के लिए कितना होगा? 2 plus 2 4 और G की वैल्यू है 1. That is nothing but 5. So A C G will be 5 which will be short. So इस साइड से A C G मिल गया. Okay. Now that means ये वाला lowest path है. So अभी क्या होगा कि next path will be from G to H. अभी A, C, G to H. Now from G to H अगर जाना है, so G to H will be equal to 2 plus 0, that will be 2 plus 2 4 plus 2 6. So again, hello. Who is speaking? Please mute yourself. Mute yourself. It's disturbing. Okay, so 6 is lower as compared to all other paths, and henceforth what will happen is that 6 is lesser than other path of the cost which on hold, and hence H is our state goal and the algorithm will terminate here. बराबर. तो अभी क्या हो गया? A से C, C से F to H, A से C, C to J to H. इन सारों को कंपेयर अगर करोगे तो ऐसा पता चलता है कि 2 plus 2 4 plus 2 6, यानी कि 2 plus 4 6, यहां आएगा तो वो बनेगा 6, यहां से जाएगा दो जगह पे 6, F कितना है? F is 3, 3 plus 3 6, अगेन C to G 6, 3 plus 6 plus 2 8, इस जगह पे आएगा 2 plus 2 4, G is 1, so it will be 5. देखो इस पाथ के कंपैरिजन में ये लो पाथ आ रहा है, यहां तक 5 आ गया. अब इस जगह पे G से H में जाना है तो उसको ये पाथ कंसिडर करना पड़ेंगे. सो G कितना है? G से H कितना है? 0. सो 2 plus 2 4 plus 2 plus H equal to 0, that will be 6. So which is nothing but the lowest total path which you have considered, whereas the other paths are on the hold, and hence you can achieve from A to H. So in this way you can get this A star search. I hope you have understood. The most important thing is that I hope that we will start all the things physical and you also start coming to the college physically, because all these things will be better taught on the board. So I'm hoping that everything will be started within 1 or 2 weeks and you should also come by, and that will be very helpful. Otherwise these things on online will be difficult to teach. With examples I can teach you on the board also. So this is how the algorithm will work out. So one path will work at one time and the other path will be holded, and then you find out the shortest path. So it is a combination of a low cost as well as the heuristic function. So low cost function plus heuristic function will combine together and you'll find out one of the algorithm called as A star search algorithm. So the path will be A, C, and G and H. So we have already calculated how this is the working of this path. So now what are the advantages and what are the disadvantages? So still we have not found out any algorithm that is not having a disadvantage. Every search algorithm will be having the advantages as well as disadvantages. So depending upon the application, depending upon the search, you can use any one type of particular strategic search algorithm in a particular application. So that depends upon what kind of applications are using. If the data is less, the memory requirement is less, so accordingly the search algorithm will be searched. Where you want a little bit faster algorithm, then accordingly again. So what are the requirement? What is your requirement for that application? Depending upon that, the search algorithms will be selected, or we can identify particular search algorithm. So the advantage of A star search algorithm is it is best when compared to the other algorithms. सारे algorithms को compare करेंगे तो ये best algorithm है, and it can also be used to solve complex problems, and also it is an optimum one. This is very good advantage that it gives an optimal solution. See, optimal solution means optimum का word का meaning है above average. So it can give you above average result. So that is also a very good thing. It can be used to solve complex problems. So this is a very small example. If you go in, if the data is huge, then this becomes really complicated. So at that time also this search algorithm will be very good. Some of the disadvantages, as it is a heuristic search and it is also based on cost, so it may not produce the shortest path. So it may not give you the shortest path, and the usage of the memory is also more as it keeps on all the nodes in the memory. So यहाँ पर hold करके रखते हैं तो memory बहुत ज़्यादा इस्तेमाल होगी. So ये कुछ उसके disadvantages है. Otherwise it is a quite good algorithm. Now if you compare the uh, uninformed and informed search, for the comparison, if you see that uninformed search is a blind search, whereas the informed search is a heuristic search. So you may be getting a question that compare these two algorithms or these two search types of algorithms, then which will be the points? So first is a blind search algorithm. It is also called as a brute space algorithm, and the informed search is a heuristic search. Again, uninformed search does not require much of the information as it is a not knowledge domain, but informed search is a completely knowledge domain kind of a technique. Compared with uninformed search, informed search are more efficient, obviously. Time complexity of uninformed is more. Informed search handles the problem better as compared to the blind search. And these search algorithms are used in games, stored databases, virtual search spaces, quantum computers, and so on. So as we know that nowadays quantum computers are going to be very rich. Research is going on as far as compute quantum is concerned. So a new concept called as quantum computers, or you may also see that quantum machine learning, quantum artificial intelligence is also coming into the picture. So these algorithms can be also used in these types of applications. So, okay, we will stop here. I hope that you have understood, because well, lot of search algorithms we have seen from last 2 days. They are very interesting, and if you find it interesting, then only they are very easier to understand. Otherwise, they'll become very tough. So I hope it is. We will stop here and we'll take the attendance.